Hello everyone and welcome back. In the previous episode, we learned how to create multiple AWS resources and how Terraform automatically manages dependencies between them. But our project still has one big problem. Everything is hard-coded. If we wanted to deploy the same infrastructure somewhere else, we'd have to manually edit the code every single time. In this episode, we're going to solve that problem using Terraform variables and outputs, making our infrastructure reusable, configurable, and much easier to maintain. Let's get started. Let's start by understanding why variables are so important. Right now, our project contains hard-coded values like the AWS region, the instance name, the instance type, and several tags. That works for a simple demo, but it doesn't scale. Imagine deploying the same project to development, staging, and production. Editing the code every time would quickly become difficult to maintain. Variables let us separate the configuration from the infrastructure itself, so the same Terraform code can be reused with different values. Let's see how Terraform variables are actually created. Terraform uses input variables to make our configurations flexible. By convention, we usually declare them inside a file called variables.tf. Each variable has a name, a type, and optionally a description and a default value. Once declared, we can reference it anywhere in our project using the var prefix. Instead of writing fixed values, Terraform reads the variable and injects the value during execution. It's much easier to understand this with a real example, so let's jump into Visual Studio Code. Variables can also have default values. If the user provides a value, Terraform uses it. Otherwise, Terraform automatically falls back to the default. This makes variables optional and provides sensible defaults for your projects. If no default is defined, Terraform will require the user to provide a value before running the deployment. So far, we've only declared variables. Now we need a place to assign their values. That's exactly what Terraform.tfvars is for. Instead of editing the Terraform code, we simply change the values inside this file. This keeps our infrastructure code clean while allowing different environments to use different configurations. In a few minutes, we'll create one ourselves. Variables provide information to Terraform. Outputs do exactly the opposite. They expose useful information after Terraform finishes creating the infrastructure. Common examples include the EC2 public IP address, the instance ID, or the public DNS name. Outputs make it easy to reuse information later or simply display the values you need after deployment. Enough theory. Let's improve the project we built in the previous episode. We'll replace every hard-coded value with variables. We'll create a variables.tf file, define a terraform.tfvars file, update our existing configuration, create outputs, and finally deploy everything again. By the end of this lab, we'll have a much cleaner and reusable Terraform project. We're back in Visual Studio Code with the project from the previous episode. Here we already have our AWS provider, an EC2 instance, a security group, an ingress rule, and an egress rule. The configuration works, but many values are still hard-coded directly inside main.tf. For example, we have the AWS region, the AMI ID, the instance type, the VPC ID, the CIDR block, the port, and several tags. Today, we'll replace those hard-coded values with Terraform variables. We'll keep the resource definitions inside main.tf, but move the configurable values into separate files. These are the values we want to configure without modifying the resource blocks every time. Before we start, I'm going to remove the commented depends underscore on example from the previous episode. We no longer need it, and keeping the project clean will make today's changes easier to follow. Before we start writing any Terraform code, let's do what every DevOps engineer should do first. Let's go to the official Terraform documentation. I don't expect you to memorize every argument or every block. What I want you to learn is where to find the information when you need it. Here we are in the official Terraform documentation. Let's search for input variables. Input variables allow us to parameterize our Terraform configuration. Instead of hard-coding values directly into our resources, we can define variables and provide different values depending on the environment. Notice that the documentation also shows us the basic syntax. We can see that every variable starts with the variable keyword, followed by the variable name, and then a block where we define its configuration. The three attributes you'll use most often are description, which explains the purpose of the variable, type, which defines the expected data type, and default, which provides a value if one isn't supplied somewhere else. Now that we understand how variables work, let's implement them in our own Terraform project. Before we leave the documentation, there's one more thing I'd like to show you. Every variable in Terraform has a type. We won't cover all of them today, but it's useful to know what's available. The most common types are string for text values, number for numeric values, bool for true or false values. Terraform also supports more advanced types like list, map, and object, which are extremely useful when working with more complex configurations. In this episode, we'll only use simple types because we're just getting started. Later in the course, we'll dedicate an entire episode to advanced variable types and learn when to use each one. Instead of searching for examples one by one, let's ask AI to generate simple examples for us. This is a great use case for AI. It helps us learn faster by creating examples, while the official documentation remains our source of truth. That's a really good summary. Notice that AI didn't just list the variable types, it also generated practical examples for each one, making the concepts much easier to understand. We have simple types like string, number, and bool, which you'll use most of the time. And we also have more advanced types like list, map, and object, which become very useful as your infrastructure grows. Don't worry about memorizing all of them today. In this course, we'll start with the basics and explore the more advanced types in future episodes with real hands-on examples. This is another great example of how AI can accelerate our learning. Instead of spending time creating examples ourselves, AI generated them instantly, while the official Terraform documentation remains our source of truth. The first file we'll create is variables.tf. This file will contain the declarations for all the input variables used by our project. Remember that declaring a variable does not necessarily assign its final value. Here, we define its name, its type, its description, and optionally a default value. Notice that Visual Studio Code is already helping us. The Terraform extension understands the language, highlights the syntax, and immediately points out mistakes while we type. It's a small feature, but it makes writing Terraform configurations much easier and helps us catch errors early. Our AMI variable does not have a default value. That makes it a required variable. Terraform will expect us to provide its value somewhere else before applying the configuration. As you can see, I'm not writing every variable completely from scratch. The Terraform extension for Visual Studio Code provides snippets and auto-completion. In many cases, I can simply start typing variable, press the tab key, and VS Code generates the basic structure for me. Then I only need to fill in the variable name, description, type, and if needed, a default value. It's a small productivity feature, but it saves a lot of time when you're working with larger Terraform projects. Since our provider currently uses an access key and a secret access key, we can also make those configurable by using variables. Notice that these variables don't have default values because credentials should never be hard-coded inside the Terraform configuration. Also, I'm marking both variables as sensitive. That tells Terraform to hide their values from the console output during plan and apply. Even though this works, remember that this is only for learning purposes. In real projects, the recommended approach is to authenticate using AWS CLI credentials, an IAM role, or another secure credential provider instead of storing credentials inside Terraform variables. Now that we've declared all our variables, nothing has actually changed yet. Our resources are still using hard-coded values. The next step is to replace those values with references to the variables we just created. Remember, every variable is accessed using the var prefix followed by the variable name. Once we finish this step, our configuration will become much more flexible and reusable. Another nice feature of Visual Studio Code is IntelliSense. As soon as I type virtuarch, VS Code immediately shows every variable available in this project. That means I don't have to memorize variable names, and it also helps prevent typing mistakes. The same idea applies to the EC2 instance. Instead of fixed values, we're now using variables. If we ever want to deploy another instance type or use a different AMI, we won't need to modify the resource itself. We'll simply change the variable value. Oops, we almost forgot something. Our tags are still hard-coded. That's actually a perfect example of why it's important to review our configuration after making changes. Let's go ahead and parameterize those as well. Right now, values like the instance name, the environment, the project name, and the managed by tag are still fixed inside the resource. Instead, let's replace them with variables just like we did with everything else. Much better. Now every configurable value in this project is managed through variables. That means if we ever need to deploy this infrastructure for another environment, another project, or another customer, we won't need to modify the resource definitions at all. We'll simply provide different variable values. You might be wondering why I'm leaving values like the protocol hard-coded. The answer is simple. Not every value should become a variable. A variable should represent something that is likely to change between deployments or environments. In our case, the protocol is always TCP, and the egress rule always allows all protocols. Since those values are not expected to change, keeping them hard-coded actually makes the configuration simpler and easier to read. Now our main.tf is fully parameterized. The resource blocks no longer contain most of the values directly, but Terraform still needs to know what values it should use. Let's go back to the official Terraform documentation. This section explains the different ways to assign values to input variables. Terraform supports multiple methods, including command line options, environment variables, and variable definition files. For this course, we'll focus on variable definition files, also known as .tfvars files. A .tfvars file contains the actual values for the variables we declared in variables.tf. Notice how the syntax is very simple. We don't use the variable keyword here. We simply assign a value to each variable using the variable name. This separation is one of the reasons Terraform scales so well. The configuration stays exactly the same, while the values can change from one environment to another. So where should those values come from? In small projects, you could put everything in a single terraform.tfvars file. But in real-world environments, we usually need different configurations for development: QA, staging, and production. Instead of modifying the Terraform code every time, we'll create a separate variable file for each environment. For this demo, I'll create a dev.tfvars file and a qa.tfvars file. I'll also add a prod.tfvars template so you can see how this scales as your infrastructure grows. The important thing is that all three environments will use exactly the same Terraform code. The only thing that changes is the values we provide. Earlier, we used default values to understand how input variables work, but now that we're providing those values through a .tfvars file, we no longer need the defaults. The purpose of variables.tf is to declare what values Terraform expects, while the .tfvars file provides those values for a specific environment. So let's remove the default values and keep our configuration cleaner and closer to what you'd see in a real-world Terraform project. Now, when we run Terraform using our dev.tfvars file, it will read those values from there instead of using hard-coded defaults. Notice that main.tf hasn't changed at all. We're using exactly the same infrastructure code, but Terraform receives different values for each environment. This is what makes the project reusable. Because these files have custom names, Terraform won't load them automatically. We need to tell Terraform which file to use with the -var -file option. Let's start with development. Before we continue, there's one more thing we need. Our provider is using an access key and a secret access key, so we need to provide those values as well. Since creating IAM users and access keys isn't the focus of today's episode, we already covered that earlier in the series. And to keep this video shorter, I've already created the credentials. I'll simply go to the AWS console, copy them, and paste them into our dev.tfvars file. Remember, these are only for today's lab. Let's initialize our Terraform project. Notice that Terraform init doesn't use the variable file. Its job is simply to initialize the working directory, download the required providers, and prepare Terraform to work with this project. The variable file only becomes relevant later, when we run commands like terraform plan or terraform apply. This is the first command that actually needs to know which environment we're working with. By using the -var-file option, we're telling Terraform to load the values from dev.tfvars. If tomorrow we wanted to deploy the QA environment, we wouldn't change the code. We'd simply run terraform apply -var-file equals qa.tfvars. If we review the output, we can see exactly what Terraform is planning to create before making any changes to our AWS account. Everything looks good. Terraform has already validated our configuration and shown us exactly what it's going to create. Now it's time to actually deploy these resources into AWS. To do that, we'll run terraform apply using the same variable file. As Terraform runs, it creates each resource in the correct order. It automatically understands dependencies between resources, so we don't have to worry about the sequence. And that's it. Terraform has successfully created all 4 resources in our AWS account. We didn't have to click through the AWS console or create anything manually. Everything was defined as code and deployed with a single command. One of the best practices after any deployment is to verify that the resources were created successfully. Let's quickly check the AWS console. Notice that the tags we defined in Terraform were automatically applied to the resources. Great, we've successfully deployed our infrastructure. But what if we want Terraform to display useful information after the deployment? Instead of guessing the syntax, let's go back to the official Terraform documentation. Just like we did with variables, we'll start with the documentation. Let's search for output values. Here we are. Output values allow us to expose information from our Terraform configuration. They can display resource attributes after a successful deployment, and they're also commonly used to share data between Terraform modules. Let's use the official example as our starting point. I'll copy it into Visual Studio Code, and then we'll adapt it to our own project. Notice that this example references resources that don't exist in our project. That's completely normal because it's just a generic example. We'll keep the same structure, but replace the resource references with the ones from our own Terraform configuration. Now that we've added our outputs, let's apply the configuration one more time. Since the infrastructure already exists, Terraform won't recreate it. Instead, it will update the Terraform state to include these new outputs. Those values are also stored in the Terraform state. That means we can retrieve them at any time without running another deployment. The Terraform output command displays every output defined in our configuration. We can also retrieve a single output by specifying its name. Output values are a simple but very powerful feature. They allow us to expose important information about the infrastructure we've created without having to open the AWS console. In larger projects, outputs are also commonly used to share information between Terraform modules. We've successfully created our infrastructure, verified the outputs, and confirmed that everything is working as expected. But we're not done yet. One of the biggest advantages of infrastructure as code is that we can remove everything just as easily as we created it. Since this is only a lab environment, there's no reason to leave these AWS resources running and generating unnecessary costs. Let's destroy everything. Notice that Terraform is deleting the resources in the correct order. Just as it automatically created the dependencies, it also understands how to safely remove them. Perfect. Terraform has successfully removed every resource that we created. If we go back to the AWS console, we'll see that our EC2 instance and security group no longer exist. Congratulations! In this episode, you completed your very first Terraform project from start to finish. We learned how to declare variables, organize our project, initialize Terraform, review the execution plan, deploy infrastructure, expose useful information with outputs, and finally clean everything up with Terraform Destroy. More importantly, you also saw the workflow that will follow throughout this entire series. We start with the official documentation, understand the concept, use AI to accelerate our work when it makes sense, validate the results, and then deploy with confidence. That's how professional DevOps engineers work in real projects. If you found this video helpful, don't forget to like the video, subscribe to the channel, and check out the GitHub repository where you'll find all the code from this episode. Thanks for watching, and I'll see you in the next episode.